Okay. Right, let's recap what we have done at the last week. So we start to understand about the functions and their behaviors. So what is function and how they behave at a different situation. Actually, first you have to learn a different kind of functions you may make. Actually, that's the things first you have to do. So then later, uh, you will learn what kind of things can be done using the functions and the some kind of operations. So that's the thing you have to do. So first, let's recap a little bit. So we understand what is the function and how we interpret the functions, the notations of the functions, and if a things behave as a function, then there is a rule to satisfy. So there are some relationships, but they are not the functions what we are called in this lecture. So what we need, if it is a function, right? So it should have to satisfy some rules. So the rule is it should have a relationship, but the function, right? In each element of the functions should have a relationship uh, in the other direction, but the relation should be one to one, right? That means we should have a unique relationship in between the domain and the range, right? So that's the thing we need, or if it does not satisfy this rule, we are not calling about it as a function, right? So in here, this figure, you can simply say these are the, so let's take, so we have a function called fx. So let's take these are the element what we have, a1, b1, c1, like that. So if we put this element to our function called some kind of relationship, then if we put this relationship onto the function, then we have output. So we call this output as our kind of the range, right? So each element has a output. So it defined as fa1 if the function is fx. So you can find the relevant output of that element by putting on that element onto the function. So see, in each element in the this domain, right? We call this as a domain of the function. So this has an exact output. So the relationship is satisfied onto one action. So we call fx is a function. So in there you can see in right hand side we call this set as a codomain. සිංහලෙන් කියනවා සහවසම කියලා. Domain කියන වසම codomain කියන සහවසම. හැබැයි for the each element at the domain we can find another set inside this codomain. So we call this set, we can give a name as a range or a set. So codomain is something like this, but inside this domain we can find out this. Sometimes codomain and the range both are equal. Sometimes range is inside in the codomain set. So these are the things, the basic things about the function. Then we try to understand the different kind of functions, right? So at the very first, we have polynomials. Then we see some rationals, then square root things inside this rational or polynomials. We talk about those, right? So there is some simple test, right, to find out if it is a function or not. So we call that a vertical test. We talk about, right? That's the thing we have done, right? So then we try to figure out the domain as well as a range of functions what we have meet in a different ways. That means we talk about the polynomials. That means like that x squared plus 5x plus 3, like that. They call these as polynomials, right? Then we talk about rationals. Rationals means we have two sets, right? So sometimes squared minus 1, x plus 1, like that. We call these as rationals. And the square root things, x squared plus 1. So for these things in polynomial, no matter, we know that each and every element in the uh, real numbers, right, we can put into this functions if it's a function, right? So no matter, but we have to care about these options, right? So the thing is, we have to think about the denominators, right? We have to think about the square roots, because we cannot uh, put negative numbers inside this square root, as well as we cannot set 0 for the denominators. So we have to care about that, right? So we solve some simple examples to find out the domain of the functions, as well as we can talk about the range also using the same scenario, right? So let's go to the last example what we have done at the previous day. So we take the function fx x squared minus 4 as a denominator is x minus 2, right? I think this is the function what we have taught at the last minutes, right? So I took this example again. I have to explain a little bit more, right? So here we can see when we consider the domain, or when we write down the domain, right? We have domain issues here because the denominator we can see at the x equal 2, positive 2, right? Then denominator goes to 0 here. So we have to uh, think about here, because we cannot apply uh, 2, number 2, to this functions as a domain. So what we have to do, right? What we did here, x minus 2 not equal to zeros. That means x not equal to 2. So a 2 is a critical point to that function, right? So we have to remove the number 2 from the domain, from the real numbers. Right? So domain is can call real numbers, but without x equal number 2. But you see here something special things for this function. We can find some factors on the numerator. So then we can simplify this rational a little bit more. So we did it. So we can write here x squared minus 2 to the power 2 here. That means x minus 2, x plus 2. So we can cancel out something, a term here, and we end up this function fx fx equal x plus 2. So what is the things here? X plus 2, you can draw the graph. X plus 2 means when the x equals 0, number 2 here, then you have a graph like that. This is the fx at this level. But we simplify. I told you we cannot remove the means domain prob issues on a function. So even if we simplify within this, if we consider only this case, right, we don't have domain issue, but we came to this equation of polynomial from here. Therefore, at the start, we have a domain issue. We have to consider that one also. If we draw a graph for this function, right, the thing is at x equal 2, we have to remove this number 2 from this function. So that means functions discontinued at this location. So we have to put a hole here, right? So in this case, x equal 2, right, we call as a hole, right? So we did not meet this kind of situation in each and every time in talking about the rationals. This is a special case. So how to identify that if this is a hole? So first we have to apply. We can apply now the critical number or domain issue to the function and see what happens. So if we apply number 2 here, you can see 2 to the power 2 means number 4. So numerator is also 0 and the denominator also 0. So if you apply or substitute the number in the domain issue number to the function, then if you see this one as a 0 divided by 0, 0 over 0, right, then definitely you can simplify that function using the factors. You can simplify and comes up to this kind of thing. And we call, then you can draw a graph like this, and but we have a hole in that domain. That is why we call this as a hole, right? I hope you can understand. So let's see the different situation that we didn't see this kind of things. Let's take an example. So I think you have note down this point, right? It's better. So sometimes I forgot to record.
Recording in progress.
Now I turn on. So anything special things, so you can note down with me, right? So so this call as a whole. Let's take another example in a different way. Let's take another function. Let's change the letter. Let's take gx. Change the function I will write down. X equal x squared minus 4 x. So gx I will take over x minus 4. Now let's see what happens. So you have to see the denominator here. So x minus 4 should not equal to 0, because if it is a 0, then we have something divided by 0. We cannot define that case. So x should not equal to number 4. Now we have a number 4. It's a special case. Let's apply number 4 first to this function. So if I apply the number 4 to the denominator, it's equal to 0. But you can see something different here. If I apply number 4 here, this should be 2. So something we have at the top, right? And denominator becomes 0. So this is another case. Earlier one, we have 0 over 0. But in this case, we have some number divided by 0. So this is also not, we cannot define, but the case is you have to identify the difference. We call in here x equals 0, x equals 2 as a whole. Right? And you know that if you apply number 2 to this function, and number 2 means any critical point to the numbers. So if it is equal to 0 over 0, that means you can take out factors and you can simplify the function. But in here, if you receive this kind of answer, that means definitely you cannot simplify this function, right? So that is the case. That's the difference on these two examples. You cannot simplify. So the thing is, we call this case, we call this number, this point, as a symptom, right? A symptom. So let's think about what is a symptom. Right? So let's try to figure out some graph and understand this case. So the number is number 4. Let's apply some numbers more than 4. If the number is, if we apply number 4 here, you can see this goes to the infinity. Positive infinity. And if we apply some numbers like that, it's equal 1000, so 3996, like that. So it's go to this. So this function will like this. Come to the number 4, it goes to the positive infinity. That. Then let's take the other part. Let's come from, let's apply number 0 here. Then what happens? 0 divided by minus 4 is equal to 0. Let's take another number. Number 2. Okay. 6 divided by minus 2. That is equal to minus 3. So you have to play on this same, not this same. That is the thing what I have to mean. Then you are playing in this end to come very near to the number 4, goes to the infinity. You come from this end. So this function, if you try to plot this graph, of this function, it should like that. So number 4, see, is the critical point, and you can see when you reach the number 4, the function goes to the infinity. Right? So we call this as asymptote, and this asymptote we call vertical. So we have to say this one vertical. Why? You can see number 4. We can draw a dashed line like this, and when function goes to the infinity, we reach this point. So that is the thing. So that means this is, if this is vertical, you should have a horizontal asymptote also. Right. So we can talk about later. So when we talk about asymptotes, it's a one type. So you may met this kind of question when you reach from the negative end to the critical point, it goes to the infinity, and when you reach the positive end to the critical point, asymptote, it goes to this. This kind of function you can as well as.
Excuse me, sir.
Hello.
Sir,
Yes.
sir, අපේ sir මේ කැඩි කැඩි ඇහෙන්නේ sir.
Then go to my voice clear.
Sir, then clear.
All right, ma'am, make a partial line on headset. Okay, thank you for your information. Right. Okay. When you are told in these kind of things, you may make these kind of asymptotes. So this is a vertical, and in the vertical category, there are some different situation you will meet in the examples. So this one way, this another way, and we have another one. So if you come to the asymptote or point, critical point, sometimes when you come from the positive end, it goes to infinity like this, and when you come to the negative end, it goes to the infinity like this. So these are the vertical asymptotes, right? So let's check whether we met this kind of example. You should have met from the examples these kind of things. Right? So in this example, we have to draw this graph as like this, and so this is a special case. When you apply the critical number for this function, right? So if you receive 0 over 0 here, that means definitely you can take out the factors and you can simplify it. And that case we mentioned here, x equal to 2 as a whole. Right? But if you receive these kind of things, then it should have asymptote. Right? Then it's the function behave as like this. But that's the difference between this fx and gx. Right. Let's take another example. I take y, not x. That can be y also a function. Right? X plus 1 divided by x minus 1. Now, so if you write down the domain, so what is the domain? You can apply real numbers, but without 1. Because when you apply 1 here, you can see denominator goes to 0. As well as you can find out another one, numerator, it will not going to 0, so you cannot simplify this function. Okay. So so this is the range. So if someone asks what is the, sorry, this is the domain. If someone asks what is the range, so you have to give an answer. So how to find the range? So range means what are the values represent the y, right? For all x values in this domain. Domain is the real numbers, and but without the x equal 1. So I will do something special thing. So x is the here we call the dependent variable, and y is the independent variable. So this here we solve out the y in this equation. So I will solve this equation for x and see the appearance of the equation. So I will take x minus 1 to this end, x plus 1, you can multiply this yx minus y equal x plus 1. Then I can take x to here, transfer y to this end, then yx minus x, y plus 1. Now I can take out x as a factor, y minus 1, y plus 1. This is equal to y plus 1 divided by y minus 1. See? Very familiar. So then we have the equation solved for the x here, equation for y. So function. So if someone asks range, that means what is y, range for y. So the same function we are talking here. We did not change the function. We only solve for x. Right. So we can do some special thing here. If someone asks y, that range for this function, right? So instead of answering to this case, here we can see we use the same function, right, in a different view, right? So here, let's assume that this is the dependent and this is the independent variable. So here you can find out the domain for y. Domain for y, right? So very similar function. So domain should be real numbers, and y should not be equal to 1 because y minus 1 is the denominator. So in this case, for this function, y behave as a dependent variable, but so that is why we call the domain for y. But you can see the same function we are talking about. So you can simply answer the range for y in this function by giving the answer, the domain for this function. But because that should be same. So the range should be again belongs to real numbers is a range, but there is a case that is y should not equal to 1. So you can find out or give an answer for range like that. That means range in this function is equal to the domain of this function because both are same. We can talk about that inverse way also. But if you look at this function again a little bit, y equal 1, that is the point, critical point. So you try to draw that one. Y equal 1 means something, what? Draw line, dash line. This is the y equal 1. So now we have to think something numbers less than number 1, right? That means these things. So for example, I will apply below than 1 means negative 100. Then what happens? If I apply negative 100 here, this is negative. Negative 100 here, this is negative. Negative over negative means positive. For this case, it should be positive. So the thing is, and definitely we know that if we come to the y equal 1, this is go to infinity. I need to know it goes to infinity in which direction. So I apply a bigger number, negative number here. So it is 1, positive. So this graph should be goes like this. Right, for this equation. And let's apply some positive numbers bigger than 1. So apply positive 100. Then numerator it is positive and denominator it is also positive. Again, we are in this set, and we know that it is near when it is near to the y equal 1, this should go to infinity, and the bigger numbers is still in the positive line. So this asymptotes looks like this. We try to draw. So you can see earlier we draw like that. Indeed, like this direction. So we call some points as a vertical asymptotes. Now, for this example, if you talk about this function, right? So, or you can talk about this way, the range of the function, again, it's called as, it looks like this, right? The range, if you plot a graph for range, it should like this way. And you have something specific case, we call this is a horizontal asymptote. So this is horizontal asymptote. So earlier we have vertical asymptotes. Now for the range, when you talk about the range here for the same function, right? This range is called this way, and we have a horizontal asymptote. So that's the things you can capture from these examples, special things. So now you have a little idea about the asymptotes, the look or appearance of the asymptotes, what is happening on the asymptotes, right? So you have to understand when you apply that number, the function goes to the infinity. There are two ways, or not two actually. different ways is happening, and there are two different categories. Sometimes it may vertical, sometimes it may horizontal. So these are you have to capture from the questions. Okay. Then we have to talk about another some functions. There are so many functions you have to learn. Now we come through polynomials, rationals, some square roots. So we made some special cases on that journey. And now we come to another function. Sometimes you make these kind of functions, even and odd, right? Even and odd functions. So we can define what is even and what is odd function. So you have to remember this. If a function, you have a function, if you apply a element or negative element like this, and the answer or output is equal to the output but we have at the positive element. But when we input the same positive element into the function, right? You can see this my note here, f minus x equal to fx. If this satisfies, this one satisfies, we call this is a even function. Let's take simple example, very simple. Then you can simply capture the same. Let's take y equal x squared like that. See, if we apply positive 1 here, y equal to 1. We apply negative 1, again y equal 1. That means f minus 1 is equal to the f plus 1. So these kind of functions, right, we can call a special name even function. Right? So you can see something special things. So here, y-axis acts as a mirror for one name. So there is a symmetry. So we can write down something more. But this one, symmetry about the y-axis. Right? So even functions should symmetric about the y-axis. You can see it on this example. Then let's try to define the odd function. Odd function is f minus 1. You find f minus x as well as if you find f x and take the minus value of that, then if these two are equal, then we call this a odd function. How to figure out this case? Using the graph, it's very easy to capture. Let's take, I will draw this kind of See, this also symmetry, right? Let's assume that if this function, I will not write down the function here, but I will put some points. One, let's take this as a 5 and take the negative one, then it is equal to -5. Then you can see the appearance. F -1. Take this point. This is equal to -5. Let's take F1, right? F1 is a positive, that means +5. If you take the minus value of this, that means minus value of this plus value. Now, these are equal thing because this kind of function has a odd function. This has a symmetric, but you can see the symmetric happens about the origin. The origin is there. So this geometric or the symmetric, not like this, we call this a rotational symmetry. That means if you have a function, then if you rotate the graph or function about the origin from 180 degrees, that means 5. Right? Then you have the same graph. You rotate this one. 5. Again, you have received the same kind of graph. This has a rotational symmetry. So we call this symmetric. You have to rotate about the origin, right? Not other points. Symmetric about the origin. Right? So this even and odd functions we can define like this way. So this capture the points using example. It is very easy to understand what is even and what is odd function. These are the special features of the function, right? So if you make some functions, because you don't know what is that, then you can see. And if it is a polynomial, rationals, and zeros, or if it is a even, or like that, you can categorize. That is why we put in some names to different kind of functions, but all of the functions. Let's take some fx. X4 power x2 plus 1. Right. This is fx. Now we have fx. Let's take f minus x. I need to find out this function is odd or even. If you apply minus x, then it should be x4. It should be x2 plus 1. Now see, both functions are same. That means we can write fx in this case equal to f minus x. That means this case. So we can call x the power 4 minus x power 2 plus 1 is a even function. So you can simply find out is some even mode or so in odd case can in odd case cubed minus x. Right? So let's check. Let's apply minus x first. Minus x times minus x. This is here. This is plus x. Let's take sorry, this is minus x here. This is plus. So let's take minus sign from this 2. Then we have x cubed minus x. So now this one we can write this like gx minus gx. So g minus x is equal to minus gx. That means this is odd function. So like that we can prove this odd or even. So when we talk about polynomials, right, sometimes we will meet even functions on that. Sometimes we will meet odd functions. So these are the special things. That means people are given the names for the functions. So we have to learn. That is the things what we are doing here. Right? For our easiest, we are naming those in odd or even like, but those are the general functions. Right. So now today we have to learn again another category of functions, that is trigonometric functions. Right. So I will teach the basics from the basics. Right. Okay, put a title, trigonometric functions. Right, trigonometric. Right. First, you have to define if we are dealing with the trigonometry. So you should have to deal with the angles. So you have to understand about the angles and how it behaves. So how to define angles? So if you draw this kind of lines and try to you are going to define an angle, then we can have to put the names. Right? So you can call initial side for this line, and for name terminal side for this line. In between this initial side and terminal side, we can define the angle called theta. Right? So how to define an angle? So we call this the positive angle. Right? Positive angles. So how to define positive angles? So from initial side, if you are define the angle in which side? What is the side? This is clockwise or anti-clockwise?
Anti-clockwise.
Yes. Clockwise, how to? What is the rotation direction? Clock? This way. This is clockwise. This is anti-clockwise. Right? So if we are defining positive angles, then it should be, we have to define in the anti-clockwise. Right? So anti-clockwise, counter-clockwise. Right? Positive angles. When you consider the counterclockwise, it will give us positive angles. Negative angles should be then clockwise. So starting from the initial side, then if we are defining the counter or clockwise, not a counter, clockwise angles, then they are negative angles. So you have to remember this. So how to define an angle is a very basic in the trigonometry. So then you will need how to measure the angle. So you, definitely you have used degrees. ආංශකවලින් තමයි අපි angles මනලා තියෙන්නේ. But in trigonometric, it is very easy to handle the values in radians. So you should have to critical understand about in between the relationship in between the radians and the degrees. So right? So we can define in radians 2 5. This should be equal to 360 degree. So when you know this one, then you can simplify the any values in radians or degrees. If you have radians, you can convert it into the degrees. If you have degrees, you can convert it to the radians. So you can simplify this one. Phi is equal to 180 like that. So think you have values. If you need to find out the radians value of 60 degree, then simply you can multiply by this one in 5 over 180. 60 means 5 over 3. So if you have radians value of 2 5 over something 3, and if you need to find the degree value, then simply you can multiply this one in 180 over 5. Okay. We cancel out 3 times 6. Then this should be 120. So you can capture the point. So we are doing the conversion here. If phi is equal to 180, then what is the value for example, this case 60. Then phi divided by 180 and multiply by 60. These things are I did here and same it here. Or you can memorize this in this way. If you have a radians, you should multiply this in 100 over 5, because in here 5 should be in the denominator, because you have to cancel out the 5 when you come to the answer in degrees. So in this case is 180 over 5. So if you need to change convert the degrees into radians, then you should contain a 5 over top. So you should multiply by this one from 5 over 180. So this conversion you have to memorize. So these are the basic, right? Sometimes you may know what I will do. Okay, for example, if someone asks from you, is mark the uh, angle called 4, 5 over 3 like that in a quadrant. So how do you can see here. This is just like 5 over 3 times 4. So this is 0, 5 over 2, 5, then 3, 5 over 2. This is the 5 like that. This is rotation. So if you mark 5 over 3 means from here to here, this is equal to 5. And if I divide it into 3, 3 equal pieces, I divide this one also to 3 equal pieces. Then I need to mark 5 over 3, 4, 5 over 3. Then this is 1, is 5, 2, 5 over 3, then 3, 5 over 3. This is 4, 5 over 3. So this is the value. If someone asks, please mark 5, 5, 3 times. 5, 5, how to 0, 5, 2, 5, 5, like that. So starting from here, you have to mark 5, 2, 5, 3, 5, 4, 5, 5. So this is the angle one. So angle is, if it is a positive, that is why we are rotating in a counterclockwise. If someone requests to mark minus 3, 5 like that, then 0 here. Starting from here, 5, 2, 5, 3, 5. So this is the angle. So there are two type of angle, positive and negative. So that is why I use clock and counterclock and clockwise directions to mark. So these are very simple things, but it's better to go or start with the basics, then you will understand the advanced things also in the trigonometric functions. If I draw quadrant and I will draw some unit portion of the circle. Right? This is unit. Unit means the radius is 1. Right? This one, this one. That is the term called unit. So then I try to draw the right angle. Right triangle here. Okay. So if this right, so unit circle, then this one should be equal to 1. because it is the radius. Then I will mark on this right triangle, the length of this axis is x and length of this axis is y. So let's take out the triangle. Right. So this is x, this is y. For this case, this is 1. Okay. First of all, it is better to understand the legs of this triangle. No? So normally, so this is the angle we have. So I will draw it here. So we call this is, so this leg is adjacent. Right, but the path. And we call this one, similar, we call Samukapadhe. So we can give the name same as opposite. This is the this leg we can understand it as what? Something like Karnaya. So can give the name, same name here. Hypotenuse. Right. Okay. So now we are going to define some trigonometric explanation for this angle. So I need to write sine value of the theta, then cos value of the theta, and tan value of the theta. Using this right triangle, you know these are the very basic. What is sine theta? Let's just write from the terms from these legs sine theta. Sine you can interpret in singular sine theta සමාන අපි මතක තියාගන්න කොහොමද? සමපාදක දෙන කර්මය. So that means opposite over hypotenuse. Cos theta බද්ධපාදයක දෙන කර්මය. බද්ධපාදක කියන්නේ adjacent. Is adjacent then adjacent over hypotenuse. Right. Tan theta. What is tan theta? සමපාදයක බද්ධපාද. Can opposite over adjacent. So these are the very basic terms what we have learned from our early learnings, right? So now we are going to apply the values for sine theta. So opposite over hypotenuse, that means opposite. In terms of y, this is y. This one is equal to 1. So now in this right triangle, we can write sine theta is equal to y. Here, what is cos theta? Adjacent, what is the value? X in hypotenuse is equal to 1. That means cos theta. Now we are doing some things in the geometry, right? So using geometry, we are going to define some relationship. That is the things in maths what we have to, right? Cos theta is equal to x. So tan theta opposite, that is y, adjacent, that is x. Right. Now you can see sine theta is equal to y, cos theta is equal to x. That means tan theta should be equal to sine theta over cos theta. You can go. So these are the relationships. if it is x, if this x is called cos theta and y equal to sin theta, here you can see something special. If this is a right triangle, you know that the equation explained from the right equation. So, what is the relationship? Square of x plus square of the opposite should be equal to square of the right. Then let's apply adjacent. What is adjacent? Cos theta. Opposite sin is equal to 1 times 2. So we can write in trigonometry, we can notate this cos theta times square like this way, cos square theta. And this one we can write sin square theta. This should be equal to 1. So this is a well known equation in the trigonometry. Sin square theta plus cos square theta, it is equal to 1. So these kind of things we can prove using some geometric relationships. That is what we have to. So you have to memorize these things. So relationship between the sine over cos is tan theta and sine square theta plus cos square theta should be equal to 1. This kind of thing. Right? So here you can we talk about only sine, cos, and tan. So there are some inverse function also from these same things. Right? That means cosec theta. Right? So that is equal to the inverse of this. That means cosec means so inverse hypotenuse over opposite. In here, sec theta is adjacent, and as well as there's a function for cot theta, that is adjacent over opposite. Right? So this should be equal to 1 by y. It should be equal to 1 by x. This is cos theta over sine. So this relationship you have to memorize. Basic function, basic sine theta, cos theta, tan theta. Then they are inverse functions. Cosec theta, sec theta, cot theta. Right? So the relationship should be like this. Okay. And then we have to memorize this one also in quadrant. Right? So you are dealing with the angles, no? So angle maybe in first quadrant. We can name this first, second, third, fourth. So angle, you are dealing angle maybe in first quadrant, second quadrant, third quadrant, or fourth quadrant. So we don't know. But the thing is, in this sine, cos, or tan, for the cosec, sec, or cot. So they are depending upon the value of the angle. They are sign actually. They are sign depending upon the this value of the angle. So we have to memorize this one. Right? What is that? The angle's value, if it is lies in between this first quadrant, all the right, all sine, tan, cos, sorry, sine, cos, tan, all the uh, values are equal to positive. They are in positive, right? Let's take, for example, if we take sine 30 or cos 30, then tan 30, all the values are in positive. So you know the table, no? I will write down from this decrease as well as the variance. Sine, cos, tan. It's very difficult to draw using this small writing pad. That is why the lines are not here. It's a line. Okay. Sorry about that. Anyhow, so this is in degrees. This is in radians. Theta. So starting from 0, then 30, 45, 60, radians. This is 0. This is 5/2. This is 5/4. So this is 5/6. This is 5/6. Is 5/3. Right. This table is very well-known table. You have to keep this on your mind. Sine 0. This is in radians. Sine 0, that is equal to 0. Cos 0 should be equal to 1. Tan 0 should be equal to 0. Then, what is cos 5/6 or cos in degrees 30? This is equal to 1/2. This is equal to root 3/2. And tan 5/6 is equal to 1/3. Then sine 45 and cos 45. In this case, both are equal. That is 1/√2. Tan 45 is equal to 1. Sine 60 is equal to root 3/2. Cos 60 is equal to half. This one. This is equal to 3. And 90. Sine 90 or sine 5/2. That is equal to 1. Cos 5/2. This is equal to 0. And this one. This is equal to. So sine the values of decrease angles in the first quadrant, right, we have some special points in this table. So you can see all the values are in positive. That is why sine, tan, sine, cos, and tan. The values comes from these uh, operations, sine, cos, so tan. They are equal to, they are positive. But when we consider the second one, so in this case, the theta angle is in this quadrant, second quadrant, then only sine, right? Only sine give us the positive values. Others are negative. That means cos theta for this case, cos theta negative. For this case, tan theta also negative. Then we are in the third quadrant, only tan theta values are positive and others are negative. That means in this theta angles, sine theta negative, cos theta negative, but tan theta positive. And in fourth quadrant, right, only cos theta negative. Others are, sorry, only cos theta positive, others are negative. So all sine, tan, cos. Right. So this is the way of remember this situation STC, right? All sine, tan, cos. So you can simply find out the values which is positive and which is negative from the sine or cos or tan operation. Right? You have to memorize this. But these are very basic. Sometimes you may learn from these basic mathematics parts. Okay. Now, using this table, you can simply find the values for this exact angles. Right? These are well defined. But if your question asks to find the angles or values for sine or cos or tan, when the theta angle is in the other quadrant, so how will we do? Right? For our easiest, we are going to define some reference angles from this quadrant. Reference angle. Reference angle means, like this case, make an acute angle with x-axis. Acute means kind of angle in between 0 and 9. Small angle. With the x-axis. So reference angle, this is the way of defining. So our theta is in like this, the first quadrant, no matter. So with the x-axis, this is the x-axis. So our reference angle directly equal to theta. Reference angle, theta. Nothing to worry about. But if our angle, this is first quadrant, in second quadrant, right, we are dealing or we are specify some reference angle. So we have to find what is the reference angle in this case. We define some make an acute angle with the x-axis. That is the reference angle. Our original angle is this, but reference angle. So again, සුළු කෝණයකින් x-axis අක්ෂයක් සමග සාදන සුළු කෝණය තමයි reference angle. So acute angle made with the x-axis. So in this case, we can highlight this is the angle, acute angle. Right? So how we define? This is 0, this is 5. So we can define this angle. How we define? This is equal to this angle. This angle we can write 5 minus theta. So in this case, reference angle is just like we have another case. If our angle is in third quadrant, so what is the acute angle? Acute angle means the angle made with the x-axis. Acute angle made with the x-axis. Just can highlight this area. So this is the acute angle or reference angle. So here reference angle we have to write out. So total original angle to this level is theta. Then that is 5. So how to write? You can write the reference angle in this way, theta minus 5. So theta is totally 5 means from here to here. Then if we reduce 5 from the theta, so we can have this reference angle. This is the definition. Right? We are following the definition because make an acute angle with the x-axis. This is the definition of the reference angle. Right? So we are depend upon this different definition. So according to definition, now we can write what is the reference angle. So in our angle in third quadrant, we can write this. And our angle is in the fourth quadrant. So now, what is the acute angle? This one. So the reference angle should be 5 total is 25. So we can mark the reference angle like this way, 25 minus theta. So in this case, our reference angle is like. So why we are defining this reference angle? It will help to find out the values of our sine operation, tan operation, cos operations very simply by combining with this table. I will show it. So if we have a reference angle, we can very easy to deal with this table. Right? So I think you can capture these definitions and the identifications of these reference angles. Okay, let's understand or capture these things using the example. It is very easy. Because without it define something, it's very easy to understand with the application. So I will take an example. So my example is find sine value, cos value, tan value of 5 5 over 3. So in this table, you have this, right? Up to 0 to 5 over, but this value is 5 5 over 3. 5 5 over 3 means it should be in. Let's check. So how to do? These are the steps you can follow. First step, locate the quadrant. Right? That means where this angle stay. Right? First quadrant, second quadrant, third quadrant, fourth quadrant. Then, if it is in the first quadrant, no matter, can directly give the answers. But we have to do something with the other spot. Then find the reference angle using this identification method. We have to find the reference angle. Why we locate the angle in which quadrant? Because without understanding the location, we cannot write the reference angle. So third step, find the trigonometric function of the reference angle. I will come to this. So let's go through these steps for this example. So what is the quadrant for this value? 5 5 over 3. So this is 0 5 over 2. 5. What is this value? 5 plus 5 5 over 2. That means 3 5 over 2. 2 5. Like that. Then you have to locate where is this. Location 5 5 over 5 5 over 3. This just pass this one because 5 5 over 3 is greater than the 3 5 over 2. So and be less than the 2 5. That means this is in the fourth quadrant, not the third quadrant. So this angle is in the fourth quadrant. Okay. We know that this term in fourth quadrant cos is the positive term. Right. Okay. Let's write the reference angle for this. Reference angle should be 2 5 over 2 5 minus theta. Right. Now we have a value for theta. Let's apply 2 5 minus 5 5 over 3. That means 6 5 minus 5 5 5 over 3. Right. Now we have a reference angle for 5 over 3. Right. Okay, good. Now we come to something angles, but we already know, right? 503 this section, right? Okay. Now what they request, all the things, no? Sine, cos, and tan. Right. Yes. Now we come to the end of this question. Now it is very easy. Now you have find the reference angle. Now the answer should be sine pi over 3, the reference angle. Now we have a reference angle. Cos pi over 3 and tan pi over 3. Now you can simply find the values. Sine pi over 3. Right. Okay. This is 2, 3 over 2. Cos pi over 3. This is half. Then tan pi over 3 is equal to root 3. Right. Is that correct? Is these the answers for these questions? Should you know? We have to consider something more, because now we define a reference angle for our ECS. Now, after we define a reference angle, we can find out the values, but we did not consider where we locate. So we are in the fourth quadrant. Right? So we have to do something more. We know that in fourth quadrant, only cos will give us the positive values. Then this is okay, right? But we have to put negative sign in front of this value because they are in negative in this fourth quadrant. So now this answer is correct. Right? So what we did here, so if we have an angle like this greater than 90 degrees, right? Or greater than 5 or 2, then if we have to find the sine or cos or tan value. So it is very easy to do it using the reference angle. Then we have to think about which quadrant that theta is located. Then we can put negative or positive signs in front of the values comes from to be a reference angle. Then we can give the answer for questions. So very simple. Right? So in this way, we can find the values for any theta. Right? I think you got this point. So these are also very basic things, right? Not new things. So I am still give gives you to the basics of the trigonometry. Right. Let's move to the graph, trigonometric graph. How to draw graph. So when you talk about the graph, for example, y equal, I will do some notations here. A times sine e x. So that the graph y equal a cos dx. Right. So these are the general representation of the equations of trigonometric equations. Right? So in terms of only sine and cos. So I'm going to draw a graph, right, of sine or cos. So I will define some variables here. So you can see if a and a equal 1 and b equal 1, then this is equal to y equal sine x. So let's define this. Why I put this a here or b here? There should be a things to put these things. Right. So I will use example and try to give the idea about these things using the examples. I think is the best way to teach you. Right. So let's take example. Y equal, very simple case, sine x. I'm going to draw this. Y equals sine x. Y over 2, 3, 5. Right, now give me answer for this question. So what is the values that can be get for the y? That means maximum and minimum value for this. It's a sine curve. So please tell me what is the maximum value and the minimum value that can I get for this equation, for this y. Sorry, 0.
Maximum is 1.
Uh,
Minimum is minus 1.
yes. Why? We know that is a sine. No? So if we are putting the numbers here, then this will vary in between 1 and minus 1. So the maximum value that can be on this curve is 1. The minimum value is minus 1. Okay. Now I'm going to draw the graph. So sine 0 should be 0. 5 over 2, sine 5 over 2 is going to plus 1. And again, sine 5 comes to 0. Sine 3 5 over 2 goes to negative 1. And sine 2 5 again come back to the 0. So original sine curve, right? Original sine curve, I try to draw just like this. So this is the y equals sine x graph, the curve. Okay, then again, let's try to plot y equal to sine x. Right, now we have to think about something. Okay, what is 2 and what is 4? We know that inside of the sine operation, right? We know that the only values, maximum and the minimum values, come from the sine operation is what? Negative 1 and plus 1. Right? So At that time, in front of this, we can see number 2 here. So in this case, our maximum, combined maximum and the minimum should be what? Can you tell me the value? මේ sin කියන operation එක ඇතුලේ අපිට ගන්න පුළුවන් minimum එක -1. We prove it. We show it here. And the maximum value එක 1. දැන් මම අහන්නේ මේ y equal to sin කියන operation එකේ maximum value එක මොකක්ද? Minimum value එක මොකක්ද? Sorry? මට පොඩක් clear මදි.
Plus 2 and minus 2.
Yes. Plus 2 and minus 2. That's the maximum and the minimum. So let's try to. Yeah. Plus 2. This is minus 2. Right. In this case, you can see something. Right? So this term, the A no, interpret something. We have to identify. That is we call amplitude. Amplitude of our sine curve. Right? So if you take the absolute value of these things, it will define the amplitude. Okay. In here, the amplitude is equal to 2. Right. Then we have something another thing. So if the sin x, so sin x go through up to 2 pi to complete single cycle. Right. You can see something different from. So what is that? So you play starting from 0, fading 0 to 2 pi to draw a complete original sine curve y equals sin x. But you can see something different here. If we need to achieve this range, you don't need to play all radians up to 2 pi. So in this case, sine 4x now. So starting from 0, I will write first is, then if you play up to 5/2, you can achieve the full range. See? Because x, this is x now. So starting from 0, you can receive the 0. And if you apply x equal 5/2, that means 4 times 5/2 means it is equal to 5. So you receive the range. That means now you are only playing up to here to complete full cycle. Right. Full sine cycle. Right. So now tell me, first draw it. Right. First draw it. And then understand. Right. This is 5/4. This is 5/8. This is 3 5/8. Yes. So the sine like this, starting from 0, then here to reach not 1, we know the amplitude is 2, they come back again to 0. I will use different color for this. 0, 1, 0 goes to 1, count at 0. Now let's go. This is the graph for y equal to sine 4x. Right. Let's we have to understand something a little bit more. Right? So you can see now if you set some value, that means initially this has also value is 1, right? Not the 0, right? Is 1 unit. But if we apply a value greater than 1, then what is happening here? The amplitude of the original PO sign, right? Right? Rise up to some value. Okay. Then that is why called amplitude. Then you can see if we have some multiplier in front of x, that means what's happened? What's happened to period? Let's call that term period. Period means right, in the PO wave original sign we have from here to here is the period. Right? Period means 1. Right? But to complete a single complete cycle, the length. Right? So in here you can see period is smaller than the original sign. Right? So we can see something like this. Okay, I will use two terms, compress and stretch. Okay, can you tell me this one, y equal to sine 4x? Right? Is it compressed version of the sine x or is it stretch version of the y equal sine x curve? Can you tell me?
Compress.
Yes, it's compressed one. Why? You can see it. So if you have a number inside this x term greater than 1, is greater than 1, that means you are going to compress the original sign term. Right? And you have to understand this also. So now I'm going to define this. What is b? Set b here. So b is equal to 4. So this give us some period, the idea about the period of this curve. A give us an idea about the amplitude as well as B give us an idea about the period. Right? So let's write down this term, period, that is equal to 2 pi over E. Okay. Now using this equation, you can apply 2 pi is 4. So period is equal to 5 over 2. That is the things what I have put to identify at first using a different basic. So this one, the PO original sign, it will take or it will play up to 0 to 5, but to complete the complete cycle of this equation inside of the sign expression, you only need to play 0 to 5 over 2. So period is 5 over 2. You can simply find out first using this, or otherwise you can understand it by your brain using like this way. Anyhow, you need to know this first. Then you know what is the range, playing area of the sign. So, and also you can understand this also. If the value of b is greater than 1 means it is complex. Now let's take about the different. I will give you two inputs using this example. Y equal minus 3 times I will take all the difference values. So here I took negative a value as well as I will take cos because I didn't draw cos operation for cos graph cos, and I will take the values for b something below than 1. This is 0.5. So I will draw or I will write like this. Yes. Now you have to consider this one, this one, this is new, this is new, this is new. Right. Because using this one, I can complete all the things. Now you can find the period. Or you can find the amplitude first. Amplitude is absolute value of this one, A, that means absolute value of 3, that is equal to 3. So amplitude, now you. And the period, 2 pi over B. B means 1 over 2. That means 4 pi. Now you know the playing area up to 4 pi. So I can't draw on this one because 4 pi come here. That is very big one. So I will draw a new graph for that. I will place this one. So and also I will take something 10 means more than more. Okay. I will close the session after 10 like that because I have to complete a little bit. Okay. Right. 4 5. Mark 4 5 here. Then this is 2 5 5 3 5. Right. Let's take the original cos curve first. Here I will write it here. Y equal cos 6. Here A is equal to 1. Period is equal to what? 2 pi over 1 is 2 pi. Right? So here is the P of cos curve because you have to know that one first. So I will draw that one on this direction. So it is easy to do. First we draw. Okay, tell me what is the minimum and maximum value that can be obtained for cos operation. You know the sign. you tell me -1 and +1. So tell me now, what is the maximum and the minimum that can be obtained for the cos of any x value? Tell me.
+1 and
Again, +1 and -1. +1, -1. So okay. What is the value for cos 0?
1.
Yes, is equal to 1. Then cos curve must goes like this way. So you know that in the complete cycle, these are oscillations at the same positions after one single cycle. So these two should be equal. Then that means to complete a cycle, we should have a minimum come to the zeroth position, and cos curve goes like this. This is the original y equal cos x curve. Right. Now we have different understand. Here we have -3 cos half x. Now we know the period. Oh, sorry. I have done some mistake. You have to correct me because cos curve might change. What is it should be 2 5. Period is should be 2 5. So this point 5/2 in 5/2. Now this one come to here. Where 0 to so this is the original cos. Right. Now our one -3 cos half x. So now you know the period for 5 and the amplitude should be 3. Plus -3. Okay. At cos here, if you apply 0 here, cos 0 is equal to 1. 1 times -3. At the start, you have to find out the starting position. 1 times -3. 1 times -3 is equal to -3. So you can start the draw from here. Now, that means just like the inverse or mirror image of the original function starting from here, because this has a -3. So its starting position is here. Then you know that kind of position should have here also at the end point. Then at the middle point, you should have the minimum or maximum, or here maximum. So your cos curve should go like this way. Right. This is the curve for y equal -3 cos half x. So you can see, right? Why this graph, the appearance of the graph is like a mirror image of the original cos curve, because we have a negative sign in front of it. That is why we have just like this shape. And you can see amplitude is something bigger than the original one, because this has a number 3. So 3 is greater than 1, right? And our period is something greater than the original one, original 1 is 5. but here 4, 5, y. This time b is less than 1. That means this graph, not the compressed, this is compressed, this is stretch. Right? Okay. So original graph stretch to something more because b is less than 1 in this case. So now you can identify the behaviors of the parameters inside this term. So if they are changing, then you can get the idea about the function. So A and B, what they did into the function. So like that way, you can draw the graph for this trigonometric functions, sine and cos also. So I think you have understand this. Give me another 5 minutes, right? I'll complete this one. So let's erase this first. We have to learn something little bit more. Now I'll write this y equal a sine. Earlier I write bx. Now I'll write bx minus c. As well as I write y equal a sine a cos bx minus c. So this is another different way of interpreting the function. Now we have another feature for coming from the letter of C. We have to identify. Let's try to simplify this as this way. A sine, I take out B here, B, x minus C over B. So that's here y equal A cos B, x minus C over B. What's the difference now? Earlier we have a sine bx as well as a cos bx. Now there's another term, right, which is inside here minus c over b. So now sometimes you may know this term c over b, right, minus c over b. It plays something. We'll add some features to the original curve. That means we call shift. Shift may be negative or positive, right? So if we have original, for example, sine curve here, if this one shift to this end, that means we call this as a negative shift. If this one shift to this end, we call it is a positive shift. Why? So we are dealing with the current function. So if you see something earlier version of the same function, that means you are in the positive shift. You are in the earlier situation. But if you are seeing some the things, same things, little bit delay means you are in the negative shift. So you have to understand the positive shift. The value of the shift can be found out using this COB term. That's the idea. Right. Let's do a example. So, and also this COB value is this value minus COB. You have to write it properly. Minus CO value is negative means minus 0 value is negative means this has a right shape. So it's better to write, sorry, right shape means because this is right shape. And this arrow indicates this as the left shape. If this is a negative means this has a right shape. This is positive means this has a left shape. Right? Okay, we have to consider the value of this minus C over B. Then we can know if this is a right shape or left shape. Very simple. Let's complete the. Let's take a simple example. Then we can put it to our mind. What is happening? Y equal cos, take cos function 2x plus 5 over 2 is the example, right? Now let's simplify this. Cos, let's take out 2, now x plus 5 over 4. Now let's write down this term into the our familiar way, x minus 5 over 4. Now this term and the way of the appearance is same. Now you can see the term right. Okay. Actually, no need to form this way also. You can take the conclusion from this term, right? Here, okay, no, this one is better. So let's take the value. Here we have to include for test minus C over B, right? You can use this one or this one, right? Minus C over B. So minus C over B means whole term x after that whole term. So x after that whole term means here what? Minus 5 over 4. Use this one. So this one is equal to 5 over 4. That means this negative C over B value is as a positive value. So that means if it is a positive means this has a what? Left shape. Right? This has a left shape like this. We are looking something earlier one. Little bit earlier one period for the time little bit time will fly little bit earlier than our original. Like that. You can think about that. Okay. Then let's draw that. We have a cos function. That's not the line. We have a cos function and amplitude. What is the amplitude? That is equal to 2. Okay. Then what What are those? Let's try to identify the period. If we know the B, we know the period, right? 2 pi over B. B means 2 pi over B. That means 2 pi over B is equal to 2. That means 5. That period is 5. Okay. 5, 5 over 2, 5 over 4, 3, 5 over 4. Right. First, I will draw the y equal cos 2x. Right? Y equal cos 2x. After that, I will think about the shift. That is the easiest way. Right? Y equal cos 2x. At the 0, this will give us, oh sorry, the amplitude is 1, okay, not 2. You did not correct me, so you have to do it, right? If I miss something, you have to correct because there is no in front of here. So amplitude is 1. I'll write 1 here. Now, please correct me. What is the example that I used at the earlier one? I used the 3 cos, so this one. Because I believe the things. Anyhow, I will take this one. Now, forget about the amplitude is 1, right? Okay. Then I will draw the cos curve, y equal cos 2x curve. So at cos at the 0, the angle is 0. This will give us a positive 1. That means here through 0, this will give us a minima through maxima. This is the y equal sine 2x curve. Sorry, y equal cos 2x curve. Now what we have to draw, y equal cos 2x plus 5 over 2. Now we'll find out the shift. Y minus c over b, that gives us a positive. That means this should have a left shift. Right? So the value of the shift is equal to c over b. Right? So 5 over 4. That means 5 over 4. Right? So each and every point will shift to left from or by 5 over 2. So this one, we write negative 5 over 4 here. So this point should come to here. This point should come to here. This point should come to here. This one here. This one here. Now you can draw the correct or final curve. The shape. So you can see this as a left shift. Okay, this is the curve. Right? What you need to draw for y equal cos 2x plus 5 over 2. So now you have learned the shift that can be appear inside of this bracket. So very easy. So now you have learned all the things, all the variables that might be appear on the trigonometric functions, so sine or cos or tan or function. We are not going to talk about the tan yet, right? Sine and cos function. I think now you have know about these basics. So after now, on next day, we can go through our original lecture series, right? So these are the things you have to learn about the trigonometric things. Then you can very easy to handle the trigonometric functions. Right? Okay. I think these are the things what I plan to give you today, right? So now it is okay. So anything to clear, you can ask now. This is your chance. Can you understand this thing or not? Please give me feedback. මම කියපු දේවල් මොනවාට තේරුම් ගත්තද ඔයගොල්ලෝ නැත්නම් ඔයගොල්ලන්ට තේරෙන්නේ නැහැ වගේ තියෙනවා නම් මට පොඩි ෆීඩ්බැක් එකක් දෙන්න.
සර් තව එක්සැම්පල්ස් ටිකක් කරන්න පුළුවන්ද?
ඔව් මම කොහමද ඔයගොල්ලන්ට සෙල්ෆ් ප්‍රැක්ටිස් කරන්න ටිකක් දාන්න මට ගිය සතියේ අතන හම්බුනේ මොකද අසා මේකත් කම්ප්ලීට් කරනකන් තමයි හිටියේ. ඊට පස්සේ ඔයගොල්ලන් ටියුටෝරියල් වර්ෂන් එකකින් මේවා ටිකක් ප්‍රැක්ටිස් කරන්න. ඊට පස්සේ ප්‍රශ්න නැතිවේ. මගේ කියන දේවල් ටික ඔළුවට යනවද කියලා මට දැනගන්න. තේරෙනවද?
Recording stopped.
කොහොමද අනිත් පැත්තට? Hello. Right. Okay. First, please go through these notes, right? Then, if there are any unclear points, right? Then you can contact me, right? So I will explain it again and again. So anyhow, actually these are not very big operations, right? These are the basic. So if you know the basics, it is very easy to handle the advanced thing. That is why I tell these things for you. So after that, if you make this kind of function later, so don't fear for the functions. You know the every features inside the function and how they act on the Cartesian or these things, this number line, right? So it is very easy to do the calculations or any other things as they request. So that is why I teach you this part. Now, next day I will move to some another operation of the function, that is combining or compositions of the functions. After that, I will move to the limit of the functions. That is the very important one, limits, because each and everything depend upon the limits. So that's the major part of the calculus. Right? So I think you can capture all the things. No need to mesmerize this, right? You need to understand this, because I will not ask to draw a graph like that things. But if you see this one at any point, you have to identify it. This is the things. This is amplitude. This is period. This is shift. This has a negative shift. This has a positive shift, like that. You have to understand. That is well enough, right? Okay. Then, okay. Thank you very much for your giving me extra time, right? Then let's meet on next Tuesday, right? Okay. Bye for that. Bye. Hello.
Thank you, sir.
Okay.
Thank you, sir.
Thank you, sir.